Hi, good afternoon. Welcome to this session for AREMA Committee 2 for the working group for right-of-way assets and clearance assessment using LiDAR. My name is Paul DiGiacobbe. I'm the Director of Geospatial Services at Maser Consulting, and I look forward to sharing some interesting information with you. So the agenda, real quick, we'll talk about the definition for LiDAR, how this technology can help railroad professionals, go through a few example applications. We'll talk about the benefits, limitations, and a few takeaways at the end of the session. So LiDAR is an acronym for light detection and ranging. It basically is a method of measuring distances by hitting a target with a laser and then measuring that the length of time. And then we turn that into points, millions of times a second. We're taking measurements to produce point cloud. The first thing I want to talk about when we speak of LiDAR are the different forms that you can use on a railroad. I've broken this into two categories, one for aerial and one for terrestrial. We'll talk about the aerial sensors now. So the first and probably most popular airborne sensor is an airborne LiDAR sensor, typically on a fixed-wing aircraft. This is technology that's been around for 25 years or so, maybe even more, I would say in production for that long. The nice thing about this technology is a very rapid collection. They're moving, obviously, at air speeds, covering broad areas with a very wide swath of coverage. As you see in the graphic here, this is a pretty large area that we're picking up in one swath. And of course, they can crisscross and double up to make sure they have everything covered. There's no impact on train operations with this type of operation. Obviously, they're working autonomously without any interaction really with the railroad. The second option is the airborne via helicopter. And what the little yellow arrows pointing to is a sensor that we often is called a pod. And really it's a stabilizer and a sophisticated set of LiDAR sensors and inertial measurement. So with that unit, they're basically able to fly the corridor itself. So rather than flying in a straight line with a fixed-wing aircraft, this is able to maneuver with the alignment of the railroad. So the more effective, more precise measurement of the railroad corridor, but very wide area coverage, very similar to what you would get in a fixed wing, but not as wide because they're closer to the ground. And again, no impacts on train operations. They're just moving autonomously across the actual route. The third option is the unmanned drone option, where these small UAS are actually carrying up to 55 pounds total weight, and they can fit a LiDAR sensor underneath them. Again, wide area coverage, not as wide as the other two because the altitude is going to be lower. But again, no impact on the train operation for this type of device to work a piece of railroad. I'll show you an example of that later on. So some of the deficiencies, all these things are really very capable instruments, but they have their limitations. Any aerial platform cannot see under things. So if you have platform canopies, or you have bridges, overpasses, or you have a tunnel, those types of facilities will not be picked up by this device. So you have to think about another type of technology to supplement that. The other thing about the UAS issue is that it is limited in duration. So they can only fly for so long, then they have to change the batteries or refuel in some manner. FAA restrictions are tight for this type of device. You have to have a 107 pilot's license, and you have to be careful of the airspace that you're entering when you use the craft. And you really have to kind of be pretty sure about what you're doing before you put one of these things up in the air. Again, with all these, they have the same line of sight issue. They're looking top down, and they don't see anything. The only other challenge with these systems is accuracy. If you're trying to do design grade technology, or you're trying to see more of the landscape and what's the furniture in the right of way, it's tough for these things to be made out from a top down. A single pedestal might be tough to see in high detail. So, but these are great instruments for gathering large amounts of data across long territories. So the terrestrial version of this technology is slightly different. This is where you're actually down on the ground. These are going to be rail mounted, either in a dedicated sense in this first image, which is from the French railroad, and then you have a mobile application with a high rail mount. So So you've got this fixed equipment that's very similar to the mobile unit. You can see there's 3 sensors on the fixed gear. There's 2 on the mobile gear. It's more of a, they call it compact, so it could be interchanged from this vehicle to another. But they do very similar things. Obviously, one's dedicated, one's can get on and off. And then the railcar profiler is very, very similar, but it's pushed by a person. And this is collecting a tremendous amount of profile information. As you push the cart, you get a profile of data. All of them provide very high accuracies. And depending on the instrument or the vehicle platform, you're going to have a different amount of track rates or impacts to the rail operations. Obviously, the fixed dedicated vehicle can operate within just like any other vehicle on the railroad. The high rail is going to need track time, limited in that they can do things in a few hours. If 2, 3, 4 hours, if they can work between trains or overnight hours, off-peak hours. And then, of course, the rail car needs its own dedicated track time. Challenges with these instruments, weather dependency for any of them, but really it's a difficult thing when you have a fixed piece of equipment you cannot get out of the rain. That's a challenge where you have to look at the weather ahead of time. They can operate in foul weather, but you don't want the data from foul weather. So you really got to look for dry conditions. The second one, obviously, the track time's a big thing, and the same thing will go for the rail car. But each one of them has their value, and they provide a specific data set for a variety of things when you get to the application side. So let's talk about some of the applications and how does this technology, LiDAR, help railroad professionals. Obviously, there's some key functions that we do as engineers, and asset management has now become really one of the key things that are required of us to maintain these rail systems. PTC updates are being done all the time with mobile systems where they are just running the system over and over again over time and making sure that everything that they believe is in place is still there. And if there's changes to the system, they want to go collect and update. Clearance analysis, we're going to talk about that and the value of having this full 3D world of points that you can slice through. Very helpful. Design surveys are obvious. This, what you're looking at on the right, is an image of a rail yard in Pennsylvania. That was a project done for SEPTA. And the rail yard is on the right-hand side. The main line for Amtrak is on the left. So what's interesting about this project is it was collected from the SEPTA property, but they were still able to get data all the way across the main line and into the wooded hillside on the left. And by the way, this is an intensity view, so you're looking at bright things are bright colors, dark things are dull, not as reflective, and then the elevation, the red is the high in the scene, and the blue is the low. So you're high to low, and then bright to dark is the contrast. Very helpful for people as engineers and analysts to look at this and see the terrain and where things are going. This was done with the drone, the one you saw in the previous image, the UAS with LiDAR in about 45 minutes, single flight, and just a tremendous amount of information was picked up. And from this, they created base mapping and helped with the redesign of some of the track in that yard. So yeah, design surveys are very helpful with this type of information, a lot of data to work from if you're working in the design environment. Alignment studies, we've done the 30-mile collection for Amtrak where they took the centerline information from the rails and produced a regressed alignment and then adjusted their curvature from that. So again, fully controlled, lots of targets out there, and then a point cloud that's super, super precise within 0.04, 0.05 of actual geodetic location. So super helpful. That's been done a lot across the globe. Planning studies are obvious. Anything of this kind of detail you can build from and look at the existing conditions and put together studies. Vegetation management's been something, cutting back tree lines and so forth, very easy to see, even in this view, as you go down the line, if something's going to impact the catenary or any high tension, that's all viewable within the 3D point cloud. And then natural disaster recovery, a lot of times, as we heard in other presentation, getting to a position in the along the railroad that has been inundated by a flood can be a challenge because all the roads and the railroad are taken out. So a drone coming in from the outside in is the best way to get an assessment, using either imagery or LiDAR to get a real good reconnaissance. So another really important thing to keep in mind is that LiDAR can measure any damage that's been done if there's displaced earth, things of that nature can be picked up from the sky. We're going to talk now about asset management and clearance analysis. These are two things that are part of this subgroup that's preparing the use of a LiDAR technology to solve the asset management and clearance analysis problems. And I'll show you some details and examples of that. So when we think of asset management, in my mind, the first thing I think of is mobile LiDAR. Mobile LiDAR is positioned on the track. It's taking high-resolution imagery. The picture on the right is actually a 37-megapixel camera that is georeferenced to the positional system, the GPS and IMU, and understands where it is in the frame of this unit. We also have a ladybug camera. That's the little red guy. That gives you the immersive street view of the world. And you put those two things together and you pretty much can show anyone anything along the project. What you're looking at in the middle picture is the actual LiDAR point cloud that's been derived from an asset management collection. And you can see the center line of the rail has already been extracted. And what we often do is create the center line station it from milepost or whatever. And then all the assets are based on offset from milepost. And it's basically station offset measurements. And then the final image at the bottom is actually like a GIS viewer showing these assets in a web environment. Let me show you an example of one of these pictures because they're pretty impressive. This is 37 megapixels mounted on the back of a high rail. What's cool is we can actually zoom in, and like this is one of the tags that we were looking for. That there's an axis on that tag, and you want to know where that axis point is. So a photo like this is extremely helpful for the designers when they're using this with a point cloud to make a determination. It also helps them understand that not everything is actually important. There's trash, things that end up that they'll be the point cloud and they'll just look like a bad anchor or something like that, and it's a can. So the photo helps you determine as an engineer when you're looking at the point cloud what's real and what's actually just trash. You don't need to worry about it. The data set, when it's completed, so we talk about making the collection. We have to process all this LiDAR and imagery, and then we start extracting assets. Ultimately, it ends up in a database. This is an example. I'm going to click on a live link for this to show you what this looks like. This is a product called UGrid that we worked with SEPTA in Philadelphia. And really what we're trying to do is just put all the point cloud and asset information into one environment. So what you're seeing here is that same image I showed you. This is the actual position of all those things. We're identifying the limits of the grade crossing platform, any shelters that might be there. This is a signal hut, I believe. So I can click on each one of these things and it's going to give me some information. So we can see our signal hut. It's got a size, length, and width and area. And that's information that the asset manager can use to actually fulfill other pieces of the overall database. But you can see the alignments on here. A lot of the information that was brought into the CAD environment has been repurposed and placed into this environment. The other thing they can do with this is actually click on any one of these little triangles, and they can look at the panographic view of the LiDAR data. So it's kind of taking you down into the point cloud so that you can look around and see what's going on. So from here, you can make measurements. You can see the geometry that's been extracted. So that's an example of having the asset information put into a geodatabase with viewing capability of the point cloud, viewing, measuring. But you get the idea that all this from the field collection rolls into something that's fairly usable to the railroad operator. Okay. So let's talk about rail clearance. That was a good example of how you can take a point cloud, turn it into assets. Let's talk about how you measure clearance when you've made a LiDAR collection. So in our experience at Maser Consulting, we've done it basically two different ways. We have the mobile LiDAR process and we have the railcar process. Both of these are producing a tremendous amount of data. As you can see in this middle picture here to the left, that's a lot of data for people to work with and make slices. The other option is to use the railcart, where someone's walking it through, usually for a specific reason. In this case, they're checking this tunnel for double stack capability, and that's ultimately going to end up in output will be put into a PDF. So really two different ways to do it. Mobile LiDAR through the tunnel, and this was actually WMATA. We did 104 miles of tunnel, and the ultimate output for that, number one, was to make sure that any of the areas where they were going to insert this cable tray were clear of the car body. So we have geometry information from the railroad, which you can see in the lower image here, these extracted lines. You've got the point cloud itself, you've got the shape of the vehicle, its static body that's been put on the railroad, and it's got, they're basically looking for anything within 4.5 inches of that shape. And that's what we look to find. In the end, you can produce a clearance report. You can also produce a CAD file that anywhere there's a tight, where we can show that in a planimetric view, looking down on the map and saying, there's a tight here, there's a tight there, so on and so forth. So that's something that's very capable of being done. The other thing on the rail cart side is that we're basically going to measure, as we walk here, we're going to take slices and looking at the inside of the tunnel against the double stack car body. But what we're going to produce there is a PDF of multiple sheets as you would walk the track. Let me click on the PDF so you can see what that looks like. So this is a stack of drawings. There's 158 slices, as you can see up here in the number of sheets. And I'm just going to roll my mouse forward. So you'll see we'll start going through the data set here. I'm sorry, here we go. So you're starting to see the dimensions as we move a few feet away. Each time I think we're moving, about 10 feet down the track. And we're getting the rail elevation, and we're also getting the clearance left and right of the car body to the top of the tunnel. So again, very simple output procedure. After LiDAR has been processed and they've done everything they need to do in the field, this is turned over to the railroad, and they have something to look at and say, okay, we can make determination from this and figure out if we have to make any undercuts or so forth. Okay, so you get a feel for how those two things work. Let me show you this is the web viewer for WMATA. And what you'll see here, I'm going to go to the yellow line right where that image was taken. And this is an entry to one of the tunnels right off the Potomac. I'm going to go in there real quick into the viewer. And this is a different type of viewer where they actually have the measuring capability within inside the viewer. Okay, let's open up the panel. Again, this is a product produced by UGrid. But very, very interesting way to use the data. Okay, so here's the extracted information from the geometry. The rest is an image from that ladybug. So the ladybug's got getting cut off at the back because we have 4,000 watts of light shining into the tunnel, so we can see everything. But then what I'm going to do over here is I'm going to just take a look at the car body, okay? And I'm going to pick a point. Let's just pick this guy right here. And it's going to tell me, it says I can't calculate right now, but I can show you the car body against that point. Let's see here. Pick up the car body. Here's the wireframe. So there we go. So that you get the idea. We're basically able to see that is clear of the car body, so that's not an issue. If we did find an issue, that would be something that would be documented and shown on the drawing. Okay, so you get the idea. All right. So let's go to the benefits. You've seen a few things about clearance and about assets. I think the point about all of this is that there's a tremendous high density of points being generated by these systems, no matter how you collect it. A lot of data. You have a very versatile methodology for controlling the data for very precise measurements like a clearance, and then you can be very loose with your control if you're doing asset management. So you choose how much accuracy you need. For most part, these are low impact on railroad operations as compared to conventional survey or boots on the ground. Big difference in how much time is spent out there, and we've actually moved from the field to the desktop, and I'll talk about that. It's a big difference for the surveyor to be actually doing this stuff, not having to actually be out in the field to make calculations. You're doing it in the office, so taking a lot of danger out of the operation. The good news about lasers is day or night, the laser can see without having daylight. The images do need daylight, so if you want images to help, like in this case, you have to collect this during the daytime. Or you have to have 4,000 watts of light, as we did in the tunnels. As I mentioned, safety's improved. We're doing way more analysis now at the desktop. The data reuse is really what's fun. Most people pay for LiDAR data for a specific reason. They needed the OCS wires, or they needed the terrain model. Find out later they can use the data for something else. So data reuse is huge. We call it data mining. Keep that in mind whenever a collection's been done, that there's always something else that it might be useful for. The other thing that I like to say after doing this for about 13 years is the repeatability. The data, if you know how to put the data into the systems and use proper control, you can repeat the same process over and over again. And that's a big deal. It's not a one hit or miss kind of thing. It's a very proven science at this point. So very reliable. So some of the limitations for LiDAR, obviously it's a line of sight instrument. So you can't see through things. So we talked about that. If you're flying an airborne sensor, it doesn't see under bridges, it won't see under a canopy. So you have to think about what you're trying to pick up when you place the sensor either in an aircraft or on a terrestrial vehicle. The targeting control is a definite issue if you need geodetic accuracy. If you need to know where you are in the world, state plane coordinates, things like that, you do need to have control placed into the scan. The aerial platforms, although they are collecting a wider swath, you have to be careful about your visibility, what you can see. Not all instruments are created the same. Remember that there's a lot of scrutiny required when you think about the type of points you're going to collect and how many sensors are on the array. You have to think about all these things because there's a lot of different types of LiDAR out there, and not all of them can produce the same results. The last thing to remember is these large data sets do require some type of a management strategy. You can see, showed you some examples of the data being in the cloud. That's a very important, thought process. If you can do it, if you can get the data out there, you're going to create a much more ubiquitous data set that people can get to. If you can't get it into the cloud, you have reasons why not, security, whatever, then you have to work with things on very large hard drives. And then you're worried about bandwidth. Moving it back and forth can become a challenge. So think about where you're going to put the data. It's not a small data set to handle. It's very large. Okay, so the takeaways. LiDAR has a lot of platforms. We talked about 6 here. Those can all be used usefully on a railroad. There's multiple outputs that you can generate. We talked about geodatabases. You can go to CAD, imagery, and an image viewer. There's a tremendous amount of things that meet a lot of different project needs. And then finally, remember that the technology is constantly changing, and we continue to see new and improved ways of doing things. So the usability and the applications, all those things are improving all the time. And I believe it's going to make for easier work for engineers in the future. I think that's the end game here, is that if you can help people with just important and design decisions and making better decisions because you have better measurements, is a really important, it's an asset to everybody that works with this type of data. So keep that in mind, that you can use it to improve your surety in what you're doing. So thank you again. My name is Paul DiGiacobbe. I appreciate your listening in and watching, and you guys have a great day.